Hey guys, so today we are going to look at some extra aspects of reflections as well as rotations. So the first part of this is lines of symmetry. Now the idea of lines of symmetry goes hand in hand with reflections. And you'll see that when we discuss what a line of symmetry is. It's exactly what it sounds like, right? A line of symmetry is a line that divides a figure into two reflecting halves. Okay, and it's really important that you note this word reflecting. Okay, they have to be reflections of each other for it to actually be a line of symmetry. So let's try some examples. Right? For A, if we folded this shape on this line, both sides would overlap perfectly. And if you think about when we did reflections on a graph, like every point has to be the same distance away from the line, that has to be true here as well. So here, you can see it would work. So we're going to say yes, this is a line of symmetry. This one, on the other hand, if we were to fold this shape on this line, it would not come out to overlap on both sides perfectly, right? You can already tell because this point, like this line right here versus this line right here, they aren't symmetrical, right? They're not two perfect reflections on each side. So we're going to say no. Okay? For the next one, we folded this shape right on that line, you can see that both sides are perfect reflections of each other. So we're going to say yes. Okay, this one, same idea. If we folded this shape on this line, right, both sides would overlap perfectly. They are reflections, so we'll say yes. Okay, last one. This is a commonly missed one. If we fold this shape on this line, okay, you can tell that it won't overlap perfectly. At first you might think it does, but let's take a look right here. This side is obviously longer than this side, right? If you notice that a side has a piece that's longer than the other side, then right away that's an indicator that that is not a line of symmetry. Okay? And that's all you need to know about lines of symmetry. You have to be able to identify whether a picture is an example of one or not. Okay, so let's go ahead and switch gears here. Now we're going to talk about how to look at a rotation and just identify or describe exactly what's going on in that picture. We've done a lot with performing rotations, but we haven't really done much with just being able to look at a picture and being like, yes, I know that this was a clockwise rotation by 90 degrees or something like that. So that's what we're going to learn how to do here. Okay, and the first step, okay, that you need to do when you are doing or identifying rotations, is to identify the pre-image, okay, and that's the original picture. And the transformed image, that's the new one. That's really important, otherwise your description will be backwards. Okay, so just step one, it's the basic identify what's the old one, what's the new one. All right, step two. Step two is to count how many quadrants. Now, don't panic when you hear me say this because you might be unaware of what that word means, but we will talk about it. Okay, count how many quadrants the image moved. All right, and here's a little key. One quadrant means that it was a 90-degree turn. Two quadrants means it was a 180-degree turn. Okay, if we were to keep going, 3 would be 270. It's all in increments of 90. okay, and so forth. We're going to focus on the 90 and the 180. And you'll see exactly what I mean when we do an example. Okay, and step 3 is to identify the direction. So when I say that, I mean clockwise versus counterclockwise. Okay, so now let's take a look at these examples and follow our steps. So in example 1 here, we can identify that this is the pre-image because this one has prime notation. So that's how we know that's the new one. This is the original, and this is the new one. Now, we want to take the shortest path we can to get to that shape. So we know that we're moving to the right, so this is a clockwise turn, and because we only moved one quadrant, right? We moved from here to the next one. And since that's only one movement, that's going to be a 90-degree rotation. And we decided that it was going to be clockwise. Okay, and I guess I'll add here too, just to remind you that clockwise means you move to the right and counterclockwise means you move to the left. Okay, so that would be our rotation. And keep in mind, we always rotate around this point right now for the sake of simplicity. So this point is 0, 0. So we're going to say 90 degrees clockwise around 0, 0. Okay, let's do one more. We know that this is the original, the pre-image. And it moves. Now this one you can actually take left or right, because if you'll notice, if we count how many quadrants we moved 1, and then we moved 2. Okay, we move 1, and then we move 2. We end up 2 big boxes away. So that tells me that we are doing a 180-degree rotation. Remember, here I wrote 2 means 180 degrees. So we've moved 180 degrees. And remember, with 180 degrees, the direction actually doesn't matter, because either way, we're going to end up in the same spot. All right, so this one, you can just say it's 180-degree rotation, and it's still around this center point. So we're just going to say around 0, 0. So really, all there is to it is to count how many big sections away it is, and then look at the direction. Okay, and that is all you need to know for your tests with regards to rotations.